Hello everybody and welcome to episode 2 of Coded Quick, the channel where I help you out with some interview questions for software engineering jobs and that kind of a thing, maybe programming competitions, by doing little practice problems that we can all benefit from doing every now and again. Today's problem is a little late because it should have happened during the holidays. We're going to be dealing with Secret Santas. I found this at the link over there. Wrong way, sorry. And it seemed topical because it's still kind of the holidays. New Year's just happened, so I know I'm probably a couple weeks late. But anyways, basically, the idea is that people want to do Secret Santas, which is when everyone randomly gets assigned one other person in the group to give a gift to, and nobody knows who has them. You only know who you have. So when it comes time for everyone to exchange the gifts, maybe on Christmas or whatever holiday you celebrate, it's a big surprise as to where your gift is coming from. So yeah, it's fun. But anyways, we want to make one where people from the same family do not get assigned to each other, which I guess people are talking about makes sense because, I don't know, you don't want to hide the gifts or, yeah, I don't know. But that was the challenge posted on Reddit that I saw. So, the way the input was coming in is that we would have lines of a text file. Each line contained a family, or if you don't have a family or you're on your own joining this Secret Santa gift exchange, then you're gonna be on a line by yourself. But so you can see my cursor, right? Yep. Joe is by himself, so he can be paired with anybody. Jeff and Jerry are in the same family, so they cannot give gifts to each other. And Johnson is by himself, so he can go. So a suitable output for this could be Joe giving to Jeff, Johnson giving to Jerry, Jerry giving to Joe, Jeff giving to Johnson. The main point is that Jeff has never given to Jerry and Jerry has never given to Jeff at any point in the output. That is kind of the biggest thing. But you notice one other thing is that this output could have solved it differently. Joe could have given to Jeff, and then Jeff could have given back to Joe. Jerry could have given to Johnson, and Johnson could have given back to Joe. And that would have created two closed loops that were still valid. And there's a bonus part to this question, which is see if you can create an algorithm that does not produce any of those closed loops. So it's one giant chain of people giving to each other, but still no people giving to people inside of their own family. So let's jump in. I'm going to do this episode slightly different than I did the episode 1. I've taken a couple notes. I'm still going to do this part where I talk about it. Let's pretend that either that this problem was just posed to my group at some competition somewhere, or maybe it was given to me during an interview. And so the first thing I'm going to do is I'm going to talk a little bit. So the example input they gave is given here. Now, it was, as I said, a text file or just a block of text, a string, a multi-line string that was broken up in such a way. I'm skipping the part where we parse it. I'm skipping the part where I split it at the new lines and into the families. Step 1 for basically every solution in my brain I could come up with was to get it into this sort of a format where it's a list of lists. Each element in the list is a family, and each family is a list of strings which contain the people's names. I'm skipping that because that is something that, like, each language can have little tricks to do. It just doesn't seem really relevant to the real thinking part of the problem. So, anyways, I just typed it out. There are 30 people here, so that means, in my mind, that because everybody is giving only one gift, there should be 30 transactions, is probably what I'm going to call them. So, or assignments, right? So Sean is going to give one gift, and somewhere in that list, someone else is going to give a gift to Sean. But there were only, because there's 30 names, we should see 30 outputs. So if we see fewer, we know we've missed some. If we see more, we know we're duplicating something somewhere, and that's not correct. Okay. I told you I skipped the input-output, and also there are some examples where this is not possible. I did not come up with this on this own. This was in the comments of the Reddit thread. I didn't read any of the answers, or I did read some of the answers, but only after I typed up my own. Like I said, I'm doing this one a little differently. I've actually prepared an answer, and we're going to talk about it. But So if you had, I did read this in the comments though. So if we have a family of 4, and then someone else, another single, this is impossible. This is an impossible setup. So maybe person A could give to person B could give to person A1 could give to B1, B1 could give to A2, and you're done, right? Person A3 and A4 are completely left out, and also no one was giving a gift to person A1, and A2 did not give a gift to anybody. So there has to be enough families or enough single people to sort this problem out. So that's an interesting little debate. But this particular set of family does have a solution. So maybe part of this challenge we could throw in there is determine if it's not possible and have a different output. We won't get to that coding today, but that is part of this problem. So if you could recognize that in an interview and say, oh, I recognize from this pattern this isn't going to happen, if there are certain inputs, that would be impressive. Okay, anyways, moving on. So the way that first comes to my mind is essentially to use search, right? So searching, you kind of pick a spot and use some sort of a search technique. And I'm going to show you like the simplest thing ever. And we are going to type it out and see if it works. Okay, so let's go ahead and I'm going to call them Secret Santa assignments. Okay, and I'm going to make that a list. So this is basically going to be our output. So as we search, we're going to be throwing things into this output. Received gifts is going to be a list of people who have received gifts. Okay, because we want to keep track of who's gotten a gift so far, so we don't give them a gift again. And also, we want to keep track of who's given a gift so far, so we don't give them a gift either. Or so we don't have them give another gift, rather. And then, really, so my first thing that I would do is, I would say let's call them family giving in families. So we're basically going to take our list of families and go through them one by one. And we're going to label them as the family that is giving. Then we're going to say for the person that is giving in family giving. So going inside that family that's giving and picking out each person, looping through them. So that's going to go Sean, Winnie, Brian, Amy, Samir, Joe, Bethany, etc. For that, we are just going to say, we're going to basically loop through families again. We're going to call this family getting. These are the people who are getting the gifts. And for person getting in, now a lot of red flags are probably going off with this code right here, and we're going to talk about that in a minute. Family getting. Or at least they should be going off, okay? I don't think it's a bad thing to start off here in like an interview or a conversation with people who are asking you to solve this problem. I don't think this is a bad starting point, but you maybe you should be at least letting them know that you're seeing something weird. Okay, so essentially what we're doing here is we're saying for every person here, search through every person in the list again, okay? Now, if not, and by the way, since last episode I've learned, if the person giving is not in gave gift, okay, what does that mean? So the person who we have selected to be the individual we are proposing should be giving a gift right now is not in gave gift. If they haven't given a gift yet, and not person getting in, what do we call that? Received gifts. Okay, let's call that received gift, singular. keep it consistent. So what does that mean? That means is the person who we are proposing to get the gift, has they not received a gift yet? And not, then we would say not person getting in family giving, right? So what does that mean? Well, that means that the person, so we're saying I cannot give any gifts to people in my family. So we could kind of check around if the person who's getting is in the same person as the family giving. It would be sort of synonymous, but just for the sake of the way we pose the problem in English, it was easy for me to say, okay, so is the person who's getting the gift part of the family that the person who is giving the gift is part of, right? So these three conditionals, I know it's really long, but these three blocks of conditionals, I put them in parentheses, hopefully makes it a little bit more easy to read. So if that is the case, then Secret Santa assignments should have append person giving, and then we'll do, this is the format that most people on the actual question post person getting. Okay, now gave gift. So this appends the Secret Santa assignments onto the person who's giving the gift, and then an arrow to say they're giving it to, and the person who's getting the gift. It's just the format of our output strings, really. So gave gift dot append person giving. So we're just saying, kind of adding this person to the list of, and then received gift dot append person getting. So now we've basically said the person who gave the gift is now inside the list of people who were keeping track of who've already given a gift. Simple. That way, when we iterate through the next thing, this if statement, or conditional here, will not return true because it's already been marked as give, as have given a gift or have received a gift, unless we're dealing with a new transaction, right? So this is just keeping track of stuff. And that would be that. So, I guess, oh, by the way, I'm switching to Python 3. I should have mentioned that sooner. So, I'm going to print, actually, I'm going to do this. Yeah, let's see. So when this is all over, we will print, I'm going to put possible solution found. Okay, and then I'm going to say for SSA in Secret Santa assignments, that's what SSA stands for, print SSA. Okay, so this is very brief code, and it does a very simple thing. For each person in our list of families, search through every other person in the list of families to see if they're valid or not. Some flags should be going off in your head, like I said. So we have a possible solution. Before we talk about anything else, let's first discuss whether or not this is correct. So how did we say we would guess if it's correct? We said that there had to be 30 lists. Well, if I select this here in Sublime, it tells me there's only 16. That's a problem. Oh, well, for one thing, this is actually, I maybe you spotted this. I actually forgot to put commas in between here, so it's merging all these into one giant name. So I was going to say, I didn't think this answer was that far off. It's not. I just goofed. Okay, and nice. So actually, just run this again, and I'll take this solution. Man, highlighting text and oh boy, PowerShell's a little wonky. Okay, that's everybody. Okay, so how many solutions do we have? 28! So close. Is it possible that my note about we need 30 lines is incorrect? Because it looks like there are a lot of the names there, right? What we could see is Martha there. Yeah, Martha's there. She's on both ends of the arrows at some point. Jane's there. So who do you think I left out? Well, if we highlight Alex, Alex is in there. Is Andrea in there? She's not. But can only one person be missing? I don't think so. I don't think only one person can be missing, right? Because, I think I forgot a comma. Yeah, I forgot the comma between Joe and Bethany. So actually, in that situation, one person could be missing. So let me run this one last time. I was going to say, that is not the same answer that I got the first time I ran a code that has pretty much the same algorithm. Okay, let's... One last time, folks. Okay. Sorry. Syntax, am I right? Alright. Still 28 lines, though, even though we've now the code has one more person in the list, because it was treating two people as the same person. Look for Alex again. Alex is gone. And Andrea. Andrea is gone. So those are the 2 lines. Marina's there, though. So it's at the end. So how did that happen? Well, it makes a lot of sense when you think about it, because if they happen to have sort of paired off or merged in such a way... I should note, by the way, this is not following the bonus at all. So there, Sean is giving to Winnie, Winnie's giving to Sean right here in the beginning. So if people have matched up in such a way, in these closed loops, where everybody has given a gift, and gifts have been given to everybody, except for the last family, this algorithm is stuck. Because, they can't give to each other anymore. So it just kind of passed them along. So maybe, yeah. Okay, so... that's unfortunate. What can we do to fix this? Now, there is one way we could do to fix it that probably wouldn't be what I would say next. But here's what you could do, okay? If someone said in an interview, how do you fix this problem? I would say, well, if you tried to address the longest families first, the ones with the most people in it, and paired them off till you just got down to these singles, you would probably solve the problem. Let's see if that's true. Families.sort, and I have to remember how to do this in Python. I think it's with the keyword key, and then you put the function to be length. This is a fancy Python reversed. We want to reverse it so we get the longest ones first. I think that's going to do what I want it to do. Oh. Did I spell that wrong? Oh, I don't think it's reversed. I think it's just reverse. Yeah. Okay. So what does this mean? This means that before getting to loop through the families, it would do the ones like Bruno, Anna, Matthew, Lucas, and it would pair them up with people like Gabriel, Martha, Philip, Regis, Juliana, and Arthur first. So here's the resulting list. I'm going to comment it out just so that if we try to run this code again, before I forget, it will be fine. So let's see, are Alex and Andrea in there this time? Alex is in there. Andrea's in there. As a matter of fact, if I copy it or select it, we can see that there are 30 lines in this file, in this selection. Done. Now, does that solve the problem always? Well, it definitely doesn't solve the problems in which this is an impossible problem, where like I said, there was a family of 4 and then one other person. That just because you start with the family of 4 does not mean that you're going to find a solution, because there is no solution. But I think if there is a solution, this might actually, and I don't know the answer, feel free to prove me right or wrong in the comments. I think this could work. Now, to the big problem. This is the part where in the interview where they say, how does this scale? which you'll hear me say in every episode. It's a question I'm always going to ask. It's an important question for today, in today's technology world. And so I would have to say terribly. Now, you should always be concerned when you have four for loops in a row, because basically we have two values. We have n, the number of families in our list. Then we have, I'm going to use a phonetically different letter, L. We have L, which is the length of the families. We can just say like the average length of families in the list. So this loop here goes through all the families, and that will be an O of n. This goes through all the persons in said families, which would be an O of L. So you have those two things put together that I would probably call that, maybe actually for argument's sake, that the O of n, because you're really referring to the number of people we're dealing with here. So either it could be a really tall list where no one's in a family, or it could be a really wide list where there's just a few families, but they've got a lot of people in them. But either way, it's the same number of people, and the loop is going to be the same time. So really, this isn't as bad as it looks, because it's really kind of an O of n, but then you have an O of n again. So it's O of n by O of n, which you don't want at all. So that means if you had more and more families and bigger families, this algorithm is going to take longer and longer to do, especially because there are some weird things you could do to like kind of trick it that we didn't do. For example, if you have given a gift to someone right now and you find a valid match for someone to give it to, don't continue searching through the family of getting and more through all the families of getting. So in other words, if Sean, as the way the algorithm is right now, Sean will give to Winnie. Okay, great. Then Sean will see if he should give to Brian and Amy and Samir and Joe and everybody else, but he won't be able to because he's already given a gift. So you could early terminate that by breaking these for loops if the if statement comes out to work. That would be a simpler way to speed it up, but that's only really chopping off a little bit per iteration. You really want to try to find some way that doesn't do this with the for loops. And now I'm going to show you my favorite answer, okay? So my favorite answer I have down here, I'm going to copy, and I took this from a Reddit post, so this is not my code, but it is something that I find fascinating and something that I think is worth talking about. So first, they import random, and this here, you don't have to worry about this. This is dealing with sort of cutting up the families from that text file in a way that they liked. And then it just loops infinitely, and then it shuffles it, and then it does a little check here to see, and we don't have to go through the code here. Basically, all you have to know is that it's checking to see if it is valid with the bonus of if there's a closed loop. So if it is, if it does happen, if it does happen to work, then it just breaks the infinite loop and it's done. Wow. So obviously this is not something I would recommend doing at an interview because it's random and this could go on forever. How does this scale? Not great, right? The more families and people you have, the more there is. But there is an idea here, because what if you had the reason why I study machine learning, and the emergence of the order from disorder is very interesting to me. So what if we sort of merge these two ideas, right? What if we said, you're going to go through every person, but when you go through every person, pick a random person who hasn't received a gift yet, and assign that, and then see if you come down to a solution where you've gotten everybody or not. And that's probably going to be terrible efficiency too, but what if you improved a little bit by saying, if you got close, do it again, but like in a similar way. Like pick similar things, and then you would, if you're only missing one person, make a lot of the same assessments, but not all of them. And this is probably going to be the topic of a future video of mine when we come back to this, where I would show you not necessarily how I would recommend doing it in an interview because of the algorithms being difficult to explain, but I'm going to write a simple evolutionary computing solution to this problem that will take some instructions, like have Regis give to Anderson, run these instructions, evaluate how close it was to coming up with the correct output, scoring it, and then taking that list of instructions and doing biologically inspired operations like mutating, or taking two of them that did really well and sort of merging them together like genes would merge in two parents, and coming up with a solution. And that is an artificial intelligence technique known as evolutionary computation, or genetic programming specifically. So that's going to take a while for me to prepare, so that might be coming down the road in a while, but I just wanted to let you know that's coming because I think it's pretty cool. I hope you found this helpful. I am sure you can beat my solutions that I've come up with here if I had to pick, I'm going to stop because the video is getting long, but if I had to pick one more topic to talk about, it would probably be maybe some sort of a graph thing. But I want to know how you guys solve this problem. I think if you were to do exactly what we did here, and include the fact that sorting really helps, and but maybe it doesn't help all the way, or does it? I don't know. I'd have to look into it farther. And you expressed that you knew that these would be not scalable. I think you'd probably still do okay. Not as good as if you typed up an answer that would be very scalable. But, let me know